All right, my mathematicians, this is the last section of chapter 2, section 9, dealing with something called weighted averages. So previously, we translated sentences into equations. In other words, we were given a verbal statement and we made it into an algebraic equation. Now we're going to solve things called mixture problems in this first video, and then in the second video, we're going to solve uniform motion problems. So a little couple pieces of vocabulary here: weighted average, mixture problem, uniform motion problem, and rate problem. So at the beginning of this section, there's this little problem. Baseball players' performance is measured in large part by statistics. Slugging average, SLG, is a weighted average that measures the power of a hitter. The slugger average is calculated by using this following formula. So it's 1b plus 2 times 2b plus 3 times 3b plus 4 times HR divided by bats. I'm pretty sure 1b stands for how many singles they got, 2b stands for doubles, 3b stands for triples, and HR stands for home runs. So you multiply and add that all up and divide it by how many times they were at bat, and that gives you their slugger percentage. The batter's slugging percentage is an example of weighted average. A weighted average M of a set of data is found by multiplying each data value by its weight and then finding the mean or the average of the new data set. Mixture problems are problems in which two or more parts are combined into a whole. They are solved using weighted averages. In a mixture problem, the units are usually the number of gallons or pounds, and the value is the cost, value, or concentration per unit. Okay, so we are going to go through a couple examples here to show you what we're talking about. So a tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Okay, so that sounds like a whole lot of information, and maybe you're not even sure what they're asking for. And that's okay. We're going to break it down and make a little table to organize our information. It's a lot more helpful if we organize the information in a table. So let W be the weight of the black tea, because it says how many pounds of black tea should be added. We don't know, so that's where the variable comes in. So let's make a table to organize. So there's 3 things that are involved here. There are the number of units, or the number of pounds of each kind of tea, the price for each pound, and the total price. So we know that there's dried blackberries, there's black tea, and there's blackberry tea. Okay, so dried blackberries, we know that there's 5 pounds of them. We know that they're $10.50 per pound, and so the total price is just $10.50 times 5. Pretty straightforward. Black tea, we don't know how many pounds of black tea. That's the question. How many pounds of black tea? I don't know. The price per pound we do know is 35, and so the total price is just going to be 35 times W. Now here's where the important part comes in. The blackberry tea. The number of pounds of blackberry tea, we don't know how many pounds of blackberry tea it's going to make. But whatever it is, it's got to be a combination of the dried blackberries and the blackberry tea. So we add those together to get 5 plus W. Okay, because blackberry tea is the total of how much blackberries you use and how much black tea you use. So we're adding that together. We do know the price, it's $25 per pound. And so the total price would be 25 times the 5 plus W. Remember, you got to put the parentheses in there. If you just have 25 times 5 plus W, it's going to look like you're just supposed to multiply the 25 and the 5. Okay, so that's the first step. Now we want to write an equation using the information in the table. So the price of the blackberries plus the price of tea should equal the price of the blackberry tea. Well, if you look in our table, we have all that information. We know the total price of the dried blackberries, we know the total price of the black tea, and we now know the total price of the blackberry tea. Well, we don't actually know it, but we have an expression that represents it. So we add those together and set them equal. So 10 50 times 5 plus 35W equals 25 times 5 plus W. Then from that step, it's just a multi-step equation with variables on both sides. Nothing you haven't done before, okay? So let's solve it. 1050 times 5 plus 35W equals 25 times the quantity 5 plus W. Multiply things out, you get 1050 times 5 is 52.5, and then when you distribute here, you get 125 plus 25W. So remember, when you have variables on both sides, you want to get all the variables on one side and all the numbers without variables on the other. So we subtract 25W from both sides to get 10W here. Now we're going to subtract the 52.5 from both sides to get 10W equals 72.5. Divide both sides by 10 and you get W equals 7.25. What does that mean? Well, that means to make blackberry tea, you're going to need 7.25 pounds of black tea to add to the dried blackberries. All right? Okay, so when you try this next one on your own, make sure you read through the information carefully, set up a table, and there's typically going to be 3 different things involved, and you're going to be able to talk about how much they weigh, how much they cost, and the total price, that type of thing. Okay, so set your table up, fill it in, and then go from there. All right, here's the question. Go ahead and read through it. I'm going to let you read through it and hit pause, and then hit play when you're ready to check your answer. Okay, we're ready. So how many pounds of premium coffee beans should be mixed with 2 pounds of supreme coffee to make the blend coffee? So there are 3 types of coffee. There is premium, there is supreme, and there is blended. Okay, now there is the number of pounds, the cost per pound, and the total cost. Now, at the end of the day, what are we trying to figure out? Well, it says how many pounds of premium coffee beans should be mixed. Okay, so premium is going to be the variable, so I'm just going to use P. Should be mixed with 2 pounds of supreme coffee. How much supreme coffee is that? 2. Okay. Now, the blended coffee, how many pounds of blended coffee is that going to make? That's going to make, well, first, before we get to that, let's do the premium cost. The premium cost is $9.50 times P. The supreme is $11.75 times 2. And so the total cost here, oh, I'm sorry. Let me erase that. Not yet. I'm actually getting the total cost there. You're just getting the cost per pound. So this is $9.50, supreme is $11.75, and blend is $10. Now the total is where you multiply them. So the total for the premium is going to be $9.50 times P. The total for the supreme is going to be $11.75 times 2. And the blend is going to be 10 times however many pounds of blended coffee there is. So the amount of blended coffee is just the combination of premium and supreme, so P plus 2. So since it's $10 a pound, it's going to be 10 times P plus 2. All right. So let's set up the equation. You'd have the total cost of the premium and the supreme added together equals the total cost of the blended. So 9.5 P plus 11.75 times 2 equals 10 times P plus 2. So it's 9.5 P plus 23.50 equals 10 P plus 20. Now I'm going to do 2 steps at one time. I'm going to subtract 20 from both sides, which is going to give me 350. And then I'm going to subtract the 9.5p from both sides, which is going to give me 0.5p. Let me write that up here. 3.5 350 equals 0.5 p. Divide both sides by 0.5. And p equals 7. Now, you have to explain, what does that 7 mean? Well, that 7 means we need 7 pounds of Supreme coffee to be blended with the premium coffee to make the blended coffee, because it needs to come out to be $10 per pound. Okay? All right. So let's go to the next one. Some mixture problems are expressed in terms of percents. So Mrs. Matthew has 16 cups of punch that is 3% pineapple juice. She also has a punch that is 33% pineapple juice. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that is 20% apple juice? Again, you have 3 things involved here. You have the 3% juice, the 33% juice, and the 20% juice. You have the number of cups and the percentages. Okay, so let X equal the amount of 33% solution to be added, because it says how many cups of the 33% punch will she need to add to the 3%. We know how much 3% punch is. There's 16 cups there. The question that they ask is usually going to indicate which one is going to be the variable. Okay, so let's make a table. The 3% punch, we know there's 16 cups. The 33% punch, we don't know, so we call that X. And the 20% punch, well, that's going to be the total of the 3 and the 33%, so 16 plus X. Now, the amount of pineapple juice, we're going to do percents, so we change them to decimals. So the amount of pineapple juice, if it's 3%, you got to take 3% of 16, so 0.03 times 16. The 33% punch, same thing, 0.33 times X. And 20% punch, 20% as a decimal is 0.20, so 0.20 times 16 plus X. All right, so then we're going to write an equation using the information in the table. So the amount of 3% plus the amount of 33% should equal the amount of 20%. So we just fill that in. 0.3 times 16 plus 0.33 times X equals 0.20 times 16 plus X. Now we want to solve the equation. So same equation here. Distribute and multiply. So this becomes 0.48 and the 0.20 distributed becomes 3.2 plus 0.2X. Combine your variables on the same side by subtracting 0.2x, and then subtract the 0.48. Now be careful, this is 3.2 and this is 0.48, not 4.8. Shouldn't really get a negative here. Okay, now you have 0.13 equals 2.72. Divide both sides by 0.13, and you get X equals about 20.9 if we round to the nearest tenth of a decimal. So what does that mean? That means that Mrs. Matthews should add about 20.9 cups of the 33% punch to the 16 cups of the 3% punch to make a mixture that is 20% punch. Okay? All right, again, it's all about making the table. So here's one for you to read. Go ahead and read through it. Try to solve it on your own, and then hit play when you're ready to check your answer. All right, we're back. So one type of antifreeze is 30% glycol. Another type is 60% glycol. How much of each kind should be used to make 100 gallons of antifreeze that is 48% glycol? Okay, so again, we have 3 things that we're talking about. We have the 40% glycol, we have the 60% glycol, and we have the 48% glycol. Now, the other 2 things that we're talking about is how much antifreeze and how much the amount of actual glycol. So a 40% glycol says how much of each kind should be used to make 100 gallons. Okay, so this column is going to be the amount of antifreeze. In this column, we're going to make the amount of glycol. Okay, because we're going to multiply 40% times whatever this is to get this. So the amount of antifreeze, let's make X. Now they didn't tell us which one. It says one type is 40%, another type is 60%, how much of each kind. It didn't really specify which one we are going to use as the variable. So in this case, you don't make them both variables. You make one variable and then subtract to get the other. Here's what I'm talking about. So if 40%, the 40% glycol solution, how much antifreeze do we need? We don't know, so we call that X. We do know that altogether we want to make 100 gallons of the 48%. So however much of the 40% we need, it's going to take up that much of the 100 gallons. So however much it takes up of the 100 gallons, whatever's left is going to be the amount of 60%. So this is where you do 100 minus X. Now that might have been the sticking point if you had trouble figuring this one out. Okay, so if I have X gallons of antifreeze and it's 40% glycol, to get the amount of glycol, I just do 0.4X. Same thing with the 60%, 0.6 times 100 minus X. And then with the 48%, 0.48 times 100. Then set up your equation. The amount of 40% plus the amount of 60% should equal the amount of 48%. So 0.4X plus 0.6 times 100 minus X equals 0.48 times 100. All right, so we distribute 0.4X plus 60 minus 0.6X equals 48. Now this one, be careful because you might get a negative. Like if you notice, the X's are on the same side. So if you do 0.4 minus 0.6, you get negative 0.2X. But notice that you also have to subtract 60 to the other side, which would make it negative 12. So as long as your answer doesn't come out negative, you should be okay. Because here, when you do the last step, you divide both sides by negative 0.2. So that means that X equals 60. Okay, so watch this. We solved for X, but the question asked how much of each kind of antifreeze should be used. Well, we're going to need 60 of X. X is the amount of 40% glycol. So we're going to need 60 gallons of the 40% mixture. And then if we use 60 gallons of that, that means we're going to need 40 gallons of the 60%. Okay, so the answer is 60 gallons of the 40% antifreeze and 40 gallons of the 60% antifreeze. Now, it's just a coincidence that you needed 60 of the 40 and 40 of the 60. Okay, don't think you're just going to switch the numbers around and skip all the work. It's almost never going to work out like that again. Just a coincidence here. But make sure you read the problems carefully and answer everything they ask. Okie doke. All right, guys, that's it for this video. We'll see you in the next one.